We want to start with organic chemistry. Let's see the definition. This is the chemistry. This is the chemistry of carbon. This is the chemistry of carbon. It deals with the study of carbon and its compounds. Carbon and its compounds. Organic compound compounds contain carbon and hydrogen, and if possible other elements, but they must contain carbon and hydrogen. And other elements, if possible. Other elements are nitrogen. We have nitrogen, chlorine, oxygen, phosphorus, sulfur, and etc. So it's centered on the carbon. Carbon is able to form many organic compounds. Is able to form many organic compounds due to its tetravalent in nature. Due to its tetravalent in nature, so it's able to form many organic compounds. What I will say now is carbon is written, it's done like this. It's tetravalent. Because of this reason, it's able to form many organic compounds. Why is carbon tetravalent in nature? You know, carbon is atomic number 6. That is 1s2, 2s2, 2p2, making 6. 1s2, 2s2. This one is subdivided. 2px1, 2py1. So there are 2 unpaired electrons. So this one will lose an electron. 1s2, 2s1, 2px1, 2py1, and 2pz1. Meaning 2s loses electron to 2pz. So it is now there are 4 unpaired electrons. So carbon is tetravalent. Is tetravalent in nature because 2s orbital loses an electron to 2pz suborbital. That is why carbon is tetravalent. So it is now written as drawn like this. So tetravalent in nature. That's the introduction. Let's see, we mentioned organic compounds is centered on carbon and its compounds. So let's see characteristics before that organic compounds. There is what we call catenation. Catenation. Carbon is able to form a long chain and the ring between to form a long chain and ring between its own atoms due to what? Catenation. So definition of catenation, meaning carbon is able to form something like this, a long chain, or it could be a ring form like this, and so on, because of catenation, meaning carbon can catenate. So catenation is the ability of an element to form bonds between its own atoms to produce chain and ring, to produce chains and rings. We call it catenation. Let's see another definition. Catenation is also defined as self-linking of atoms of an element to produce a long chain and ring. So self-linking of atoms of an element to produce a long chain and ring. This is another definition of catenation. So an element that catenates is nothing but carbon. It's nothing but carbon. So hence carbon catenates. Properties of or characteristics or characteristics or properties of organic compounds. What are the characteristics or properties of organic compounds? One, they are covalent compounds. They are covalent compounds. That is, the bonds in them are majorly covalent bonds. So hence they are covalent compounds. Okay, e.g., you take C2H5OH, for example. This is ethanol. Methane. Take methane, for example, CH4. The bond between two nonmetals. You still remember the bond between two nonmetals? We call it covalent bonds, where there is a sharing of electron between two non-metals, and the electron to be shared is being donated by both of the participating atoms. So we call it a covalent bond. So they are covalent compounds. So as such, they have low boiling points. They have low boiling points. So I will say Take note of this. There are some organic compounds that they do not have low boiling point, e.g. ethanol and co. Because, so exception to this, some organic compounds, they are Hall covalent compounds. Some organic compounds do have high boiling points. High boiling points due to the presence of hydrogen bond. Due to the presence of hydrogen bond. Take note of that. E.g. ethanol. Like ethanol, the boiling point is 78 degrees Celsius, which is high due to the presence of ethanol. Remember, this ethanoic acid, even ethanoic acid, that is Ca3COOH. We draw the structure HC. So this is here, you have the hydrogen bond. The effect is it raises the boiling point of an organic compound. So some organic compounds do have high boiling point due to the presence of hydrogen bond. You can use that to explain. Take note of that. 3. They are insoluble in polar solvents. They are insoluble in polar solvents. Example of polar solvent, e.g. water, meaning they are insoluble in water, but soluble in non-polar or organic solvents. Take note of that. They are generally insoluble in water, polar solvents. A very good example, please take note of that. We have an exception to that. The exception is like glucose, for example. Glucose is an organic compound. It's an organic compound which is soluble in water, due to the presence of hydrogen bond. In the glucose. Take note of that. If you have C6H12O6, this is your glucose solid, add water to it. It will dissolve to form glucose solution, C6H12O6. So to give glucose solution. Please take note of that, due to the presence of hydrogen bond. Then, what are the effects of hydrogen? Note, the two effects of hydrogen bond on the physical properties of organic compounds are: 1, it raises or increases the boiling point. point of an organic compounds. 2, it enhances the solubility of organic compounds in water. These are the two effects of hydrogen bond on the physical properties of organic compounds. An organic compound is expected, so far it is equivalent compounds. They are covalent compounds. They are expected to have low boiling point. But once hydrogen bond is present, it raises or increases the boiling point of such organic compounds. So organic compound is insoluble in polar solvents, e.g. water. What makes them to be soluble in polar solvent is due to the presence of hydrogen bond. So these are the two effects of hydrogen bond on the physical properties of organic compounds. So let's see 4. They have low melting point. They have low melting point. The assist, they have low melting point. They exist as molecules. They are poor conductor of heat and electricity, while some are weak. Take note of that. Some are used as weak electrolytes, e.g. organic acids. Take note of that. Number 7, we have organic compounds containing carbon and hydrogen. Organic compounds containing carbon and hydrogen only are called hydrocarbons. They are called hydrocarbons. Organic compounds containing carbon and hydrogen only are called hydrocarbons. They are CXHHY. So let's see 8.